Namaste everyone, this is Disha, an electronics and communication student at Sri Venkateshwara College of Engineering. I am here to give a presentation on Reflex Klystron oscillator. Contents to be discussed are definition of reflex klystron, construction of reflex klystron, operation of reflex klystron, application of reflex klystron. What is reflex klystron? Firstly, klystron are basically specialized tubes used as amplifiers and oscillators at the microwave frequency range. Reflex klystron is a specialized low-power vacuum tube used to produce oscillations at microwave frequency. Reflex klystron basically works on the principle of velocity and current modulation. For the construction of reflex klystron, we need electron gun, a cathode filament, an anode cavity, an electrode at the cathode potential. Reflex klystron provides low power and has low efficiency. In this slide, we discuss about the construction details of the reflex klystron. This is the diagram of reflex klystron. The electron gun emits the electron beam which passes through the gap in the anode cavity. These electrons travel towards the repeller electrode which is connected to the I potential of the repeller voltage. Due to the I negative field, the electrons repel back to the anode cavity. While this return journey, the electron emits or gives the more energy to the gap, and these oscillations are sustained. It is assumed that oscillations already exist in the tube and these are sustained by its operation. The electrons while passing through the anode give some velocity or gain some velocity. Operation of reflex klystron. The operation of reflex klystron is understood by some assumptions. The electron beam is accelerated towards the anode cavity. Let us assume three electron: reference electron, earlier electron, late electron. Let us assume that the reference electron crosses the anode cavity but has no extra velocity. It repels back after reaching the repeller electrode with the same velocity. Another electron, let's say earlier electron, which has started earlier than this reference electron, reaches the repeller first but returns slowly, reaching at the same time as the reference electron. We have another electron, that is late electron. The late electron starts later than both reference electron and earlier electron. However, it moves with the greater velocity towards the repeller electrode, while returning back reaches at the same time as reference electron and earlier electron does. Moving on to the next slide. Now these three electrons, reference electron, earlier electron, late electron, reach the gap at the same time, forming the electron bunch. This travel time is called transient time, which should have an optimum value. This is the figure which shows that the earlier electron, reference electron, late electron reaches the gap at the same time and forms the electron bunch. Transient time. Transient time is defined as the time taken by the electrons to return to the cavity gap after getting repelled by the repeller electrode. For sustained oscillations to take place, transient time is the most important factor. Basically, the optimum time for leaving the gun is centered around the reference electron, which is considered at a 180-degree phase shift or phase difference from the sinusoidal applied potential across the gap. To calculate the transient time, we use the formula T is equals to n3 by 4, where n is integer, n3 by 4 is in the form of mixed fraction, and usually we know that transient time depends upon the repeller and anode voltage. And a diagram here is shown the bunching process. Here the x-axis represents the time and y-axis show the distance travelled by the electrons inside the tube. The operating frequency range generally offered is 1 to 20 GHz, and it delivers output power in the range of around 10 milliwatt to 2.5 watts. The tuning range of Klystron lies between 5 GHz at 2 watt to 30 GHz at 10 milliwatts. Theoretically, the efficiency is considered 22.78%, while practically the achieved efficiency is only 10 to 20%. As firstly I have told that reflex Klystron oscillators gives the low efficiency. In this slide, we see the applications of reflex Klystron. Reflex Klystron is used in applications where variable frequency is desirable, such as radio receivers, portable microwave links, parametric amplifiers, local oscillators of microwave receivers, as a single source where variable frequency is desirable in microwave generators, etc. Thank you for watching my video. Please like, share and subscribe.